On the last video, we pretty much configured the layer 2 infrastructure across both the main campus and the secondary campus. So today, or at least right now, I'm going to just do a quick video on configuring or how to configure point-to-point links. And what this is going to do is this is going to enable the communication to the core part of the network. So the two campuses, and there's more to it than just configuring point-to-point links, but the idea, at least for right now, is both campuses, while they have internal communication within themselves, so building A, B, and C in the main campus can communicate between themselves. The main campus and the secondary campus cannot communicate with each other, and that's because they're on two separate networks. And in order to do that, we are going to need to set up point-to-point links between the distribution switch and the core switch for the respective campuses. So we're going to need to configure point-to-point connection between the campus distribution switch and the main campus core router, the secondary campus distribution switch and the secondary campus core router, and then we're also going to need to configure a point-to-point link between the campus core router and the secondary campus core router. Now, there are going to be some people that are going to point out, well, realistically, you're going to traverse the internet, so there would be some sort of MPLS environment, here in between the two campuses, or there might be some VPN tunneling and things like that, but those are more advanced topics that we'll deal with in a later video. For right now, we're just going to make the assumption that the only thing we need to do is make sure that there's a connection between the main campus core router and the secondary campus core router, and then the point-to-point links between the distribution layer and the core network, core layer of the respective campuses. Once we do that, we'll be one step closer to making sure that we have communication between both campuses, the secondary and the main. So let's get started. So I've gone ahead and I've turned on, oh no, I hadn't turned on these two. So I have to turn on these devices. I have to start them. Now we'll start working with the main campus first, and actually what I should do is I'm actually going to label these so I know them. The campus is going to be 172.16.1.0, and I'm going to make them a /30. Now there's two routes you can go with this. You can do a /30. Now a /30 will give you 4 IP addresses with 2 addressable hosts. You'll have your network address, your broadcast address, and then your 2 hosts. You'll typically see these in a lot of environments. Now IPv4 addresses or the availability of IPv4 addresses are getting smaller and smaller and smaller, which is why we're seeing the shift over to IPv6, or why IPv6 was created, among other things, right? It doesn't break end to end, for IPsec and things like that. It doesn't break end to end security like NAT will. There's a workaround you have to do with NAT to get that working properly. But realistically, it's because back in the 80s and 90s, with 32-bit addressing, it's like we'll never run out of IP addresses. Yeah, we're out. We're pretty much out. So you design your networks. You want to use the network that's going to have the minimum required number of hosts. If you only need 4, then you're going to do a /30. Now that won't allow you to scale, obviously, but on a point-to-point you don't, because by definition you only need one point and the other point. I'm going to briefly bring up RFC 3021, because RFC 3021 is another workaround to the IPv4 problem. A /31 only has two addresses you can use. So it's a directed broadcast. So there really is no broadcast address. So you can use the two hosts that it gives you. You'll see enterprise networks now start using, if they're not using IPv6 for point, you'll see them start using /31s, because you only need the two addresses. And if you want to look up the actual RFC and do some reading on the white paper and the specification, you'll find it here. This is what it looks like, just briefly. However, in my lab, I'm not worried about running out of IP addresses. This is not a public addressable space, so I just went ahead and did the /30, because at least for right now, that's what you'll most commonly see. So the core, and I have this all written again. I write everything down, so I have my whole IP addressing scheme here, VLAN scheme, and all that. So I'm not doing this from memory. Or I could, but you start introducing some problems, because if you do an address space wrong, or you have IP conflicts, and we want to avoid that. So we're doing the 172.16.1 here. And then let's see, the main core in the cloud, which we'll do we're actually going to make a mock internet in this space here. We'll do that at another point in time in another video. Save my /30. And then we'll do the secondary distribution to the secondary campus, 172.16.1.8/30. And then the main campus to the secondary campus is going to be a 172.16.1.12/30. Here, move that here, and we'll move that here. So right now we have the networks for our point-to-point links planned out. So now we're going to go ahead and we're going to go in and we're going to configure them. So the first thing we're going to do is we'll configure the main campus first. Now, in a previous video, I had mentioned that default gateways, 9 times out of 10, I'll use the first addressable host in that network for the default gateway. So for all of these SVIs, they're virtual interfaces, not physical, they're virtual interfaces. So for all of these SVIs, I used a .1 address, because these were going to be the default gateways. Now that we're moving up to the core layer, between the distribution and the core now facing inside the network is going to be the .1, because the campus core will be the default gateway for the internal network. So this physical interface here will be .1, and this physical interface will be .2, and will be the same thing for the secondary campus. Secondary campus core will be the default gateway for the internal network here, so that's going to be a .1, and that's going to be the .2. So starting with the distribution switch, and remember, excuse me, I have to move my cat. Let's take a quick look at the routing table. Okay, so brief recap. We have all of our VLAN addresses because they're directly connected or locally connected in our routing table. So the distribution switch can make routing decisions across the internal network based on VLANs. Now what we're going to do is we're actually going to configure the physical interface IP addresses. Yeah, so this is now we're really working with layer 3. So without having my topology up, what you can do is show CDP neighbor, and you can see here that I am connected to the main campus core router, and I'm connected on local interface 00. So I'm going to go int G00 and IP address 172.16. This campus to main core, right? Yes. Now because this is facing or going out, this is not going to be the default gateway for the internal network. I'm going to make it a .2. 255.255.255. Now this is a /30 network. So this is going to be a 252. Oh, that's right. Because I'm using the layer 3 switch. Okay, technically, it's a switch with routing capabilities. You don't have to do this on a router, obviously, but on a switch, or layer 3 switch, actually, no, I was in the interface. I'm going to no switch port it. Now I have it as a no switch port. Now you see the line goes up. Because the switch port really is for layer 2 access devices only. Or layer 2 only, I should say. Not necessarily access devices, because you could use, you can make SPIs, you can do VLANs, and so you don't necessarily have to have an access device plugged in. But if you want to leave it in your head that if I'm just connecting devices, it's layer 2, that's what the switch port is. Switch port. So I essentially disable the switch port feature on the port that I'm going to use as a physical interface for layer 3 routing. So now that I've done the no switch port command, I can now set the IP address 172.16.1.2, 255.255.252. So let's verify. We'll do a show. We'll show IP. Show IP interface brief. And now we have our 00 interface. We now have an IP address assigned. And let's just verify that that was the correct interface to use. And if I can type properly, 00, 00, we're okay there. Now, let's just take a look at the routing table. Because that interface is now up, we now have that 1.0 network. It's directly connected, and we see it's connected through interface G00. So that's good. There is only one point-to-point link. It is the only interface that faces the core router. So with the distribution switch, we are done. So let's go ahead and let's configure the campus core. Now I've configured the host name. I didn't do any of the security features like I wouldn't say security features, but I didn't configure a username or a secret password or anything like that on the core router. I'll do that at a later point in time, but that's not available now or active now. In case you're wondering why it was on the other ones, not anything special. I just didn't do it. So let's take a look at the routing table. Maybe I did configure this already. my computer ready. So, what we're going to do, just so I can show you how to do it, G0, 0, so I'm going to run the default command, which essentially sets the interface to their default configuration. And because now it wipes the IP addresses, they're going to go down. I really need to set that to the buffer, or to go to buffer instead. So now, if I do a show run, no IP addresses on the interfaces. None on 00, none on 01, 02, 03. None. Perfect. So we'll pretend that it wasn't previously configured. So now, CDP neighbor. And we also have to wait for that table to come back up. Well, it won't because the interface is down. So, G00, 0. And we know that because if we look, 00 is connected to 00, the campus switch. Sorry, I had a brain fart. And we're going to do IP address 172.16.1.1.255.255.255.252. We're going to no shut it. Brief to double check. I might have used this configuration for a different lab, and it's because I'm working on I've probably pulled the image from a different, but that's okay. You know what, we'll work with what we got. So gig ethernet 00 is now configured with an IP address, and if we do a show run, we'll see it here. Now we can start fiddling with the settings for duplex and speed depending on the other side, which switch, what speeds are, what speeds are running, things like that. We're not going to do that at all. In this, at least not in this video. So now we're good. So we should theoretically be able to ping the other side. It takes a second for it to kick in, but there we go. So we have both links up. We have connectivity between the main campus core router and the distribution switch. And now if we look at the routing table, there's our directly connected network. So perfect. Now we can communicate between the distribution and the core. Moving on to the next one. Now we're going to go across the lane. So we're going to configure the main campus core. Oh, and these are still not running. Now they're on. Okay. So now we're going to go from the campus core to the secondary campus core. And this is connected on the interface G02 to G01. The thought process I'm having here is which one of these is going to be what address, right? Is this going to be the lowest number or the highest number? See, obviously we're not going to use a .1 because this is the network address is .12, so this is not going to be a .1. For the sake of the lab and for simplicity, I'm going to use the first, as I'm moving left to right across the lab, I'm not going to, actually, better idea. This will be the lowest or the first address in the network. Why? Because this main campus core router is the router that faces the internet. Because I'm not using the internet in the middle here to connect the two campuses, I'm just going to assume it's a direct connect that we'll just use it as a direct connect. This router faces the internet. So this will eventually be the default gateway to the internet for the secondary campus long term. So I'm going to use this one as the first addressable host in the network on this point-to-point link between the two routers. We'll do it that way. So the main campus core. Now I'm going to configure interface G02. And this is going to be IP address 172. Now we're moving on to a different network. So this is going to be the main campus to the secondary campus. It's going to be .16.1.13, 255.255.255.252. And I'm going to no shut it. And actually what I want to do is, because I did make configurations that we validated, I'm just going to go back and save the configurations on the distribution switch. I forgot to do that. Now, let's do a show IP interface brief. And now interface G02, which is connected to the other router, is up and assigned 172.16.1.13. We'll do a show run. And we can verify it as the same on a /30. And then we're also going to look at the routing table. And there is the /30 network. The .12 is the network address. There's a /30. This is the IP address for the actual interface. Perfect. We'll save. Now moving on to configure the other side. Let's go to the secondary campus core. This one I did not configure at all. So let's do this real quick. Let's just add the boilerplate configuration I have for the router. Copy. Once that comes up, or fully comes up. This is when I take another sip of coffee. Enable D. We're going to insert the boilerplate config. And this one is going to be secondary campus core. Oh, some names it doesn't let you use. So we'll just call it secondary campus. Save that base config. Now, we'll do a show CDP neighbor. It probably won't because the interface is down. So let's go back and look at the topology just so we can verify. So now, we're interface G01 is facing G02. So we're going to configure G01. Int, sorry. Int G01 172.16 and it was 1.14.255.255.255.252. No shut. Get out. And now the status automatically changes up to up. It doesn't automatically. I know I did a no shut on it. So let's go ahead and we'll check interface. As you can see, interface G01 is up. We'll do a show run. There we go. And then we'll go ahead and do a show IP route. And there it is. There's a .12 network, and here's the IP address for the interface. Perfect. So now, if I wanted to test the connection and ping the other interface address, there we have. Now we have connectivity between the two routers. Perfect. We'll save. Now, if you wanted, you can also verify by going to the actual interface details itself. I'm going to show interface G01, and you can verify that way. So you can see that the line is up, see the IP address, the bandwidth. Now, because it's sending CDP packets and things like that back and forth, you'll see the packets input, packets output, and then if we do a show CDP neighbor, now you can see that because both links are up, it's receiving information. It knows that it's G01 is connected to G02 on the main campus core. So for this, in this instance, we verify connectivity across the point-to-point link. So this is done between the main campus core and the secondary campus core. So now we're going to do the same thing, and we're going to go ahead and we're going to go over to the secondary campus distribution switch. Oh, type that in wrong. There we go. So I'll do a show CDP neighbor, and because the interface is down and not communicating, we don't have any entries here. So we see interface G00 is connected to G01, and since this is the default gateway for the internal layer 3 communications, this is going to be the first addressable host. This interface is going to be the first addressable host on that network, and this will be the second. So G00. So we'll go to interface G00, the address 172.16.1.8 networks. The next one 9.10.251.252.252. Again, layer 3 switch. I have to no switch port it. Now I can make the IP address, and it's up, and now it'll automatically go up. And interface brief. You can see interface G00 has the IP address assigned. Now, if you go down here, notice the VLANs, their statuses is down, down. This wasn't, if I had changed it, you would see administratively down. The reason why these interfaces are down, because I actually didn't turn on the switches that it's connected to. So the secondary distribution switch is going, I can't reach the interfaces on the connected devices, so it turns its ports down. If I turn them back up, these will turn up, those interfaces will go up automatically. The reason I do that is because for VM constraints, usually if I'm not using a particular device or I'm testing on a particular device, I'll spin it down. Those two devices are down, which is why these interfaces are down. So 172.16.1.10, we're good here. IP route. There's that .8 address, .8 network, .10 address. We're good here. And realistically, once you check the brief, if you see it's up, you see the IP address is there, you already know that you've configured it correctly. I'm just showing you multiple ways to go in and see the same information just to double check yourself. So the running config, we're good. Routing table, the address is in there, and in the interface brief, it's there. If you want to go a step further and do a little bit of overkill, then we'll do a show interface G00. It's up, it's connected, IP address is signed in a /30 network. Here's the 1 gig bandwidth. We're done. Now let's go over to the, well, let's save the configuration. Now we'll go over to the secondary campus core. We'll do a show CDP neighbor just to see something, and only has the one entry. Okay. Believe this is interface G00. Okay, so now we're working with interface G00 on the campus core. So this is going to be the first addressable host on this .8 network, because it is going to be the default gateway for the internal network as a whole, with L3 communications going to the outside. Internally, this is the default gateway for the devices. Externally, traversing the network going out towards the internet, this is going to be the default gateway. And that was G00. Okay. And G00. No switch port. Or did we do that already? We might have done that already. So, oh, sorry. It's a router. We don't need to do that. IP address 172.16. This is an 8 network. .9 252. No shut. And then we're going to check it. Show the show IP interface brief. And there we go. G00.8.9's up. It's assigned. We'll do a show run. Here's the configuration there for that interface. We're good. We'll show IP route. That 8.8 networks in the routing table. We're good here. So I should realistically now be able to ping 172.16.8.10. Give a second for ARP resolution. Ah. Let's check again. Give you a second to see if we can spot the error. You found it yet? Okay. I messed up my IP addressing scheme. 172.16.1.1. I put .8. So this is technically on a whole different network altogether. So how do we fix this? No big deal. One of two ways. You can go into the interface, which was G00, and you can either give it an IP address, reset it, or you can do a no IP address, put in the old IP address, .16.8.9, 255.255.255.252. Do show IP interface brief. Notice how that IP address is now gone. And then reassign it the correct interface, the correct IP address, 192.16.1.9.255.255.255.252. We'll end. See, it's not enough to see that something's configured. You want to make sure that the configuration is correct, which is why we always test. So show run. 172.16.1.9. Okay, good. And we'll do a show IP interface brief. We're good here. Show IP route. And we have the 1.8 or the .8 network. We've got the .9 interface. We're good. So now if we ping 172.16.1.10, give ARP resolution a second. Now we have connection between the secondary core the secondary campus core, and the secondary campus distribution switch. Now, can we go from, can we hit the secondary campus core? Can we now hit the 172.16.1.1 address on the other campus core? Let's see. 172.16.1.1. Huh. We can't. Wonder why that is. Well, let's take a look at the routing table. We have 172.16.1, but the only networks we have connected, or we have in our routing table, are the .8 and the .12 networks. It doesn't know how to get to the .0 network. So when I asked to ping this address here, which is really on the 172.16.1.0 network, it checks its routing table and says, I don't know how to get there, and drops a packet. So how do we fix that? Now we're going to start getting into routing protocols, and we'll get to that in another video.